Hi, my name is Mark Sarazano. I'm a registered piano technician with the Piano Technicians Guild, and I'm a full-time piano technician from Montreal, Canada. This is the third podcast in a series of podcasts for the website howtotunepianos.com, the podcast that discusses the hobby, skill, and career of piano tuning. In this episode, I want to discuss the topic of stability. Now, when we tune a piano, each string is set so that the pitch is at exactly the precise frequency that we want in order for the piano to sound good. Maybe we're tuning unisons. If that pitch is exactly the same as the other string, we got a clean unison. Maybe we're tuning octaves. If you've got a nice clean octave, you've set the frequencies of each note so that it sounds great. Maybe we're doing a temperament. Each interval changes in its beat speeds smoothly and evenly in equal temperament so that all the intervals sound equally out of tune and everything sounds great. However, after you set the pitch, if it doesn't stay there, it doesn't matter how good you were at tuning unisons. It doesn't matter how good you were at tuning octaves. It doesn't matter how good you were at tuning equal temperament. It's all going to be ruined. And it doesn't matter whether you tune by ear or using an electronic tuning device, software. It doesn't matter. If you don't have good stability, it's all going to sound horrible. So, in order for us to get good stability when we're tuning, we have to understand a little bit about what's going on. First of all, we have the tuning pin. It turns in the pin block. But when you turn the tuning pin, it twists a bit before the whole thing moves in the pin block. We call that moving the foot. Sometimes it's an audible click that you can hear. Sometimes it's just a feeling that the whole thing's moving. We also have the string from the pin to the V-bar. This changes in tension as you turn the pin. And when the tension gets great enough or small enough, the string will slide over the V-bar. This is a very important point that not everybody realizes. You don't get a change in pitch unless the string slips across the V-bar. You really don't have to think about much what's going on. What you really only need to think about is, am I moving the string across the V-bar? Because if it doesn't move, the pitch doesn't change. So, in the process of tuning the string, I have in my mind what's happening at the V-bar. Now, what's happening before the V-bar, the non-speaking length, and the tuning pin is quite complicated, but I've tried to boil it down into some very simple ideas. And in the future, I hope to have a course online that describes and helps you test yourself on these elements. But for now, let's just try and identify some of the things that are very important. And that is the length of the non-speaking length. That is the distance that the piano string has from the V-bar up to the tuning pin. If it's short, the pitch reacts differently than if it's long. The tuning pin itself bends, twists, it deforms when you're tuning the pin, when you're turning it. And for the very final change in pitch, that little tiny movement that we have to effect on the string so that it moves over the V-bar the smallest amount so that the pitch is exactly where you want it. In order to get that to happen, we're not really moving the pin a lot. And most times, we're not moving the foot at all. It's just some kind of deformation in the pin itself. So, we can think that in that final motion, there's only a constant amount of deformation we have available to us before the pin foot starts to move. And then we're dealing with some pretty difficult pianos if you have to start moving the pin foot around to get that final change in pitch, that final minuscule change in pitch that you want. So, for a consistent amount of pin movement, we have a varying amount of change in the non-speaking length tension. I'm going to show you now a video that I took in my backyard with the help of my son Eric and daughter Emma. In that video, Emma's going to represent the tuning pin. She's going to be moving back and forth, but she's going to keep her feet still. She can't move her feet and step. This movement that she's going to have is going to simulate the movement of the pin when we're doing that final motion. I am going to be representing the string on the V-bar, the part of the string that's sitting on the V-bar. If I'm moving, that means the string is moving, and that means the pitch is changing. And the non-speaking length will be simulated with different lengths of bungee cord. So I'm hoping that this demonstration will help you visualize the importance of the length of the non-speaking length and how what we do to the pin affects the actual pitch and tension of the non-speaking length differently depending on how long it is. Hope you enjoy it. Thanks for watching. Welcome to How to Tune Pianos. In one of my posts on Piano World, I discussed the elasticity of the non-speaking length. And in this video, I'm going to show you an example of a real world, well, not really real world, it's a made up example that will illustrate the effect of the non-speaking length elasticity on stability of the piano. When we tune a piano, we're moving the tuning pin. Now the tuning pin can twist and it can bend. And if we're doing the last final motions on that pin, trying to get the pitch precise, we are really only, most of the time, I am anyways, most of the time, just dealing with that tiny bit of twisting and bending. In other words, the foot is not moving. I've chosen these bungee cords to illustrate the elasticity of the non-speaking length. In pianos, often we'll see the non-speaking length being very short, like this bungee cord. But there are some pianos as well that have very long non-speaking lengths, and I am giving you this bungee cord to represent the length of those non-speaking lengths. And now with the help of my daughter Emma, can you come up? And also my son Eric, who is helping me. Do we look okay?
Yeah.
What I'd like to do is show you what the motion of the pin, the effect that the motion of the pin has on the string as it's sitting on the V-bar. I'm going to be the string sitting on the V-bar. Emma's going to be the tuning pin. Now, remember I said that the tuning pin doesn't turn. The foot doesn't turn. So there's only so much motion that is available to the pin without having the foot turn. And Emma's going to demonstrate that by moving without moving her feet. Can you do that? Let's see. Just move back and forth. Yeah. Okay. So now, if I'm moving, it means that the string is moving across the V-bar. Okay, Emma? You can see now that I'm moving, and it's quite obvious that I feel her pulling on me. So the V-bar is feeling it. When you move the pin, the V-bar feels it on a short non-speaking length. What happens on a piano that has a long non-speaking length? Here you go, Miss Tuning Pin. Here, take the end. Go as far as you can. Keep your feet where they are and pull back and forth. As you can see, she's moving back and forth. This is the same as moving the pin back and forth with some torsion and some elastic deformation, and I don't feel anything. I hope that I've been able to explain to you, showing this demonstration with bungee cords, how the final motion of the tuning pin, which generally does not involve moving the foot unless you need to, I hope that it's shown you that what you do to the pin has more or less effect on the string on the V-bar, depending on how long the non-speaking length is. I hope this can help in your journey towards trying to achieve better stability while tuning pianos. Thanks a lot for watching, and stay tuned.